Hi, Andy. Welcome.
Hi, Alexei. Thank you for making time to talk to me.
Yeah, sure. So, so can you tell us a few words about you and about the tool you're going to show us?
Yeah, so my name is Andy Dang. I'm a co-founder and the lead engineer at Whylabs, where we're building an AI and data observability platform. And at the moment, what we're working on is an open source project called Whylogs, and that we are building it to enable and like in the infrastructure agnostic observability for machine learning and data. So I'm really excited to share the project with you all today.
Yeah, that's very cool. So I think you have a demo for us, right?
Yes, so let me just get started with by sharing my screen. Uh, what we're building at Whylabs is a tool called Whylogs, and what Whylogs aims to do is to provide a standard for data and machine learning, uh, both from the tooling perspective and from the standard definition perspective. So what we're doing at the moment is we're building this tool in two languages, Python and Java, because these are the one language is very popular for the machine learning, and the other one is very popular for big data engineering world, both of which are tightly coupled when it comes to solving AI and machine learning problems. And what Whylogs does is that it can be run in various environments from your own Jupyter notebook, which I will use in the demo today, to your deployed container for your models, or your big data processing pipeline in Spark, Flink, or Kafka. And the way Whylogs does this is by providing very lightweight statistical profiles or summary of the data distribution in a distributed way, in a mergeable way that allows user to then aggregate and run insight generation. It is different from traditional machine learning analysis tooling in the sense that it decouples the statistic collection part, as in where this can happen where the data is. For example, it can happen in your prediction container, your deployed container, and then it can then be analyzed later on in a separate environment or separate stage of your pipeline, like your Jupyter notebook. So what Whylogs does is actually very simple in terms of the statistic collection, that it collects a various distributions. For example, one is histogram, the other one is unique value in the data stream. And we also do things like frequent items for categorical features. And this allows us to run various analysis and enable Whylogs users to have better insight into the machine learning pipeline. We also built a backing storage format using protobuf that enable us to run this across different languages, so that the library can then be run in both, for example, in Java, and then analyzed back in Python, because we have Jupyter Notebook, for example. Speaking of which, I probably will switch to a very simple demo from our example. We have a lot of example notebooks, but I'll get a basic notebook example running to demonstrate what it means to run Whylogs. So, what's in the? Yes, let me make it bigger, and let me hide. How to hide the sidebar? There you go. So, and let me restart the corner. So here is an example notebook from our repo, and what it does is it install Whylogs in your environment, and we also bundle a simple data set called Landing Club. So Landing Club data set is a very popular data set that is, you can find this on Kaggle, various Kaggle challenges. It's basically a data set with various information about user who want to loan money. So what we do with Whylogs is that using a few lines of code, we can then build simple statistics across this data set. And this is a very basic one-on-one use case. We start with a configuration file. So this allows user to specify some metadata information, such as the project name or the pipeline name. These are not fully required in the sense that you can, they're pretty much the way fits into your pipeline, how you organize your machine learning or your data pipeline. And then more importantly, you can then save the output to your local disk in this case, but then you can also save the output to S3 or your cloud storage, or you can write your own custom writer in this. And this allows us to basically store this protobuf profile in a central location, and then you can run analysis later. In this notebook, everything is done locally. So just to show you the workflow, but in practice, we have users who store data like these profiles in S3 and then often have a separate notebook to run the analysis. So to start with Whylogs, we start with a session which basically contains all the configurations about the writers, where the profile should go, and other more like Whylogs level configuration. And you can just quickly log a data frame, and this will generate the output in the Whylogs output folder, and it will be of the form of dataset profile batch, for example. So I just go a demo dataset here, and that's why it got this name. But yeah, you can customize how the dataset can be logged based on your need. And then once you start logging it, then you can also use some more like log context manager logger API, where if you have a continuous stream, sorry, let me hide this sidebar. Continuous stream of data, you can also use the logger API, which I just lost. Oh, yeah, that is, where is it? Here, the logger API, where you can use a with statement and you can then log the data frame. Say if you have continuous stream in a container, you would not close the logger at this point, but continuous logging. So all these concepts we try to map it to the Python logger concept, where the log can then be rotated, for example, so that you can do it over time, or in case of batch processing, you probably will just do it, we'll just close it as the training step or the processing step is finished on your local machine. And then once you log these profiles, the question is, what do we do with them? Because you collect all these statistics, and they're a summary.
Why do we actually log them? So I'm just wondering, so we have a data set, right? And then we log this data set. So why the data frame? Why do we want to do this?
Yes, because a common problem that we see in machine learning and in big data pipeline is that it's very expensive to run analysis on data. And when you have a lot of data sets stored in S3, and you want to run or in a SQL database, and you want to run analysis on them, you will have to execute expensive queries. The way Whylogs approaches this is that as you produce the data or as you receive the data, you provide these small log files in the form of summary statistics, and then you can run analysis later. This will become clearer once I do the MLflow example, why to show one of the properties of Whylogs, of what we call distributed merging. So yeah, again, think about it as being able to analyze the data without having the actual full data set. Like you don't have to download gigabytes of data set back to your machine. Instead, only the profiles, which is very small, in the order of megabytes, and very lightweight. So I will skip through all this where we demo various formats here. Let me see if I got the sum. So, I haven't run the profile. Okay. So here we're trying to just create what we call a Whylogs profile. And the summary object here is a human readable view. So we have, and let me run it to make sure that it shows what it contains, is that it contains very basic information like mean and max. And all of these are aggregatable. So if you add two profiles together, then you get a total. So for example, here the count is 300 items. So I can do another merge. What I'm doing here is just merging two profiles. Say somehow I get profiles from two sources and I want to add them together. Then what you get is double the count. But well, in this case, the min and the max will be the same, but we also do things like quantiles. And these quantiles are actually extracted from our dynamic histogram sketches. And because they're sketches, so you can actually rebin these histograms, because this is for the summary format, we just want to make it very simple. So we just extract some very basic summaries out of here. But the idea is that you can then have all this information readily available in the profile. And then once you have these output, like this is another view of the data from a given feature, then again the same view, but we just transposed it to a table to make it very clear. And then if you look at this over time, then you can start detect issues like data drift or data quality issues by looking at things like how many unique numbers there are in the stream. Because if there's a spike, something's wrong with your data or something has changed with your data. And some example of round trip. Another thing to go out is that once you have a bunch of these profiles over time, then you can start visualizing them. And what that means is that basically you get a time series distributions of things. And we build some out of the box plotting mechanism here. And here you're just looking at the quantize of values over time. This is a very common technique to use that is used to detect data drift or data distribution. We actually have some example notebook on top of this. I'm going to quickly jump to the ML. Actually, before jumping to other example, I want to show that if you have the correct library, then you can use a thing called a profile viewer here, which is another way to visualize the data, where if you pass in, we are working on supporting multiple profiles, but here you can see we're trying to make a static report where user can then share this as an HTML file with their colleague about the distribution of data. This can be a good way to track data distribution over time, but all of this can be done by just saving the profile, and then you can have various ways of looking at the data without actually storing the full data set again. So I'm gonna be cognizant of time. I'm gonna wrap up in terms of the very quick demo. We have tons of other examples in our Whylogs example, including a Spark example. If you are curious about running profiling with Apache Spark, which can scale to, we have use cases. We have seen people doing this on terabytes of data set, because it's very lightweight. It doesn't require accessing the storage, transporting all the data around. It actually just requires the profiles. We can also detect data drift, which is, I'm going to scroll to where the section where it does is, again, using the quantile distribution. And if you layer them on top of each other, you can then detect data drift visually, or you can use some fancier algorithms like KL divergence or KS distance or Hallinger distance, or I think there's earth mover distance as well. So all the distance algorithm can be applied to this metrics to then detect data drift. And then we have various integrations with existing machine learning pipelines, tooling such as MLflow or images. So these, feel free to check out the examples. We list all of them in our public repo, and we are, yeah. So that's pretty much the very quick overview of Whylogs, and I know that you probably have a lot of questions, so I'll pause
Yeah,
here.
I noticed that I think it was Whylogs for Scala or Java,
Yes.
or I think I noticed that there is a pull request, right? So how can people contribute if they want? Like, what's the
Yeah,
process?
so the process is pretty simple at the moment. If most of the time we start with an issue, so you have to identify an issue. You get pick an existing issue, and then or you can cut an issue to a repo, and then we can then triangulate and form a technical approach, and then we can cut the pull request. If it's a kind of major feature change, if it's just a bug fix, then we welcome just anyone to cut a pull request directly. Just keep in mind that our all these are under Apache 2 license. So as long as you are okay working with an Apache 2 license library, which is pretty standard nowadays, we'd be happy to take contributions.
Okay, what are the gotchas with Apache 2?
The Apache 2 license, in terms of gotcha, I don't think there's much any gotcha. I think the only thing is around waiving the intellectual property kind of when it comes to the library. You probably don't have, my understanding is that you can't sue people who are using the library for the intellectual property content in the library, which means companies can adopt it. That's my rough understanding, but I'm not a
Okay.
lawyer.
Yeah, I was just wondering why you explicitly told us about that.
Yeah.
Okay,
It,
so what are your plans?
so the plan for Whylogs, there are two angles. One, oh, by the way, we have a Slack channel as well. So feel free to join our Slack channel, which is at the top right. Our plan is twofold. One is to integrate Whylogs with a lot of machine learning deployment and training and data engineering pipelines. So we have Apache Spark, we have a private version of Apache Flink working, like we're testing it internally. And we have a Kafka integration from both Python and Java. So because Kafka supports both. And then for machine learning, we are working on we got extending the MLflow integration to support more model deployment, more model types and more real-time model deployment. And SageMaker, we have example in how to integrate with SageMaker, but we want to support other model hosting frameworks like KF serving or Qflow as well. And then there's the angle of data type support. So we have some support, basic support for images and text. We want to extend that to other kinds of complex data types, such as videos and embeddings. And those are more challenging from the data science side. We need to figure out the right approach, and in a way, it has to be lightweight. It has to be distributed, MapReduce friendly.
Okay, that's awesome. How many people are working on this project?
We have there are two engineers who are actively working in this from Whylabs side, but we have various people from like both data science and engineering working on different angles. So the data science team contributes mostly in terms of prototyping, the data science like data extension, extending support for data types or kind of anomaly detection use cases. And then the engineering team, they're working on specific integration, for example, SageMaker. So we have kind of like two core engineers who are driving this from the API design and direction, but then we have smaller contributors around this.
Mm-hmm. Yeah, interesting. Do you have any advice for anyone who is watching this?
My advice is that if you start building a model pipeline, think about how you can monitor and detect issues with respect to data in that. And I'm not saying you should use Whylogs, but if you have a lightweight, even lighter weight solution like retrofitting Grafana, for example, and Prometheus to detect data quality issues, please do, because this tend to be an afterthought for a lot of practitioners out there when it comes to monitoring. They might have a pipeline, but they don't have a way to monitor that because monitoring tend to become the second thought after the fact, and it's harder to change the architecture once you deploy it.
Okay, thanks a lot. Thanks for the demo. Thanks for the advice. Thanks for joining us today and showing the tool. Thanks.
Yeah, thank you very much for your time.